Hello.
Hello.
Hello, guys. Welcome. Don't forget to like, subscribe.
Yeah, thanks. Okay, so 4 types of relations. So we are moving on, obviously. So we're up to 3i, 4 types of relations. If you recall back at the start when we were doing 3b, we looked at a little bit at the relations. Namely, I think it was just what functions were, and that a relation was any ordered pair. For our functions, we used the vertical line test. So if we had some Cartesian plane and some function there, that's a parabola, and we can test by just taking vertical lines anywhere on there. And if any vertical line test fails, then we'd know, oh, this is not a function, it's just a relation. For example, if we have something like this, then vertical line test through there, oh, my vertical line is passing through 2 points on the graph, therefore not a function. We're going to look a little bit further into this now and see the main 4 types of relations, which are one-to-one, many-to-one, one-to-many, and many-to-many. So the first 2, so one-to-one and many-to-one are functions, and any linear equation is going to be a one-to-one. In fact, any, not any cubic equation, but certainly a cubic, not quite like that, because that passes through there and there, so that's no good. But some cubic equations are also one-to-one, but any quadratic or parabola is going to be a many-to-one function, meaning that many values of x correspond to one value of y. And that's how we're doing it. It goes x to y. Okay. So this, I'll just read this out. This section introduces the corresponding horizontal line test. So we have our vertical line test, which tests whether our relation is a function. The horizontal line test doesn't actually test whether the relation is a function. It does test for something else. It in fact tests for one-to-many relations. I think it's one-to-many. Yeah, it's one-to-many. And it does tell us if the inverse of a function is going to be a function. But I don't think we deal with that in this section, but something that we've touched on in the extension class. So the horizontal line test, classifying relationships into the 4 types depending on what their graph goes through. So that's essentially what we're going to be doing, is classifying what these graphs are going into, which kind of relation. Is it a one-to-one, a many-to-one, a one-to-many, or a many-to-many? Those are the 4 there. Now, how I've managed to remember it, as far as which is which, is one-to-one. Obviously, one-to-one is a function, no big deal. But then I was always getting confused between many-to-one or one-to-many, and it's alphabetical. So one-to-one works, that's fine. But between many-to-one and one-to-many, the many-to-one is a function, and that's the alphabetical one as far as M comes before O, and that's how I've remembered. So however you want to remember it, that's fine. That's what's worked for me in the last few days, weeks, something like that. Okay. Yeah. So when we're doing a horizontal line test, we're essentially, how they've described it here is like reading the graph backwards, and that kind of tells us whether or not the relation that's happening here. So the few examples they go through. Okay, here we go. Sorry. So there are a few examples of relations and functions whose domain and range do not consist of numbers. Such relations don't appear very often in this course, but are vitally important in the databases and spreadsheets that we use every day and the internet record keeping. Just a side note, it's not particularly important, but certainly don't have to write it down. So using horizontal lines to read a graph backwards. So here we have a graph of the temperature, which is y. The y-axis is the temperature. Y degrees Celsius measured x hours after midnight over 2 days. So over 2 days, effectively the x-axis here is hours after midnight and from the first day. So, you know, if we're looking at 30 hours after midnight, obviously that's somewhere in the next day. Is it the next day? Yeah, in the following day. But that's fine. It's just hours after midnight. No big deal. So the function is y equals f of x. Y equals f of x is like saying y equals y. No big deal. The function of x is equal to y. That's all great. So straightforward way. So if we want to read this normally, we would say to take a time, we'd say x equals 2. So at 2 hours, what is the temperature of whatever it is, of the, what are we after? Just the temperature after midnight, okay. So after 2 hours, then we'd look on the horizontal axis to where x equals 2, and we'd see it's around about there, I'm assuming, is what they're implying there. And draw a vertical line at x equals 2, so around something like that. And we'd see where does that intersect with the graph or the function. And then we'd dot that across, so we say, oh, well, that intersects with the graph at y equals 5. So the temperature must have been 5 degrees. So after 2 hours, the temperature was 5 degrees, and that's what we'd say. So substituting, if we had our equation there, well, we can say that function of 2, instead of function of x, function of 2, replacing x with 2, is equal to 5. We don't actually know what the function is yet, and frankly, I'm pretty sure that's not a real function. Oh, well, it is a real function, but it might not be a real relation. I'm not sure. It would be possible to somehow plot that, but I'm certainly not going to try. But yeah, anyway, point being, we don't know what the equation of that function is. Well, we don't need to know. That's fine. So we can read the graph backwards, but when we read the graph backwards, something different happens. Well, obviously, when we're reading it forwards, if we're looking at the x-axis, there is only one corresponding value of y when at the 2 hour mark, right? But if we read it backwards, if we look for 5 degrees and say, well, what time, how many hours after midnight was 5 degrees? Well, then, and draw a horizontal line through there, well, we're going to intersect in quite a few different places. So obviously, our original answer is going to be there, yes. At 5 degrees was 2 hours after, but 5 degrees is also, around there, which is what, 7 or 8 hours after, and then around there, 24 hours after, 30 something hours after, 40, yeah, something like that, hours after, and then down here. And we can see they've listed down below each of those things. So we can read the graph backwards, take a temperature at 5 degrees on the vertical axis, and then draw a horizontal line to see where is it passing through. And so clearly, when y equals 5, there's many values of x. So it's a many to one situation where many values of x correspond to one value of y, and that keeps it as a function. So yeah, the temperature after 5 degrees was 2, 7.5, 24, 38, 45.5, that kind of thing. So they've said f of x equals 5, then these are the values of x that are possible. So using horizontal lines to read the graph backwards, it's just essentially that. Like we can plug a horizontal line through here. If I went, through here, then I've got a value there at 10, a value there, sorry, at 0, a value there at, what, 7 or 8 or something, another one there at 20-ish, whatever it may be. So it's just doing things in reverse. Normally we plug x in to get y, but we also have experienced plugging y in to get x. Every time we want to find the x-intercept, that's effectively what we do. We plug in a 0 value for y, and then solve to get x, and we get lots of complicated things like that with quadratics and our factor theorem and remainder theorem and all that. Oh wait, we've been through the factor theorem and remainder theorem. Okay, yeah, okay, so different class. All good. So using the horizontal lines to read the graph backwards. So it says to solve f of x equals b, b being some value. On the graph, we draw a horizontal line at y equals b, so say that was 5 in this case, and read off the corresponding x values. So thus we're reading the graph backwards, starting with y and looking at the corresponding x values. And it's just the opposite, that's all. So that's kind of a precursor to what they're talking about there as far as the horizontal line test. So the horizontal line test tells us the kind of relation that's existing in the function or between the two axes, if you will. So that one above, I'm pretty sure some people would know what that one above was. What kind of relation was this graph up here that we're dealing with? Is it one-to-one, many-to-one, one-to-many, or many-to-many? It is a many-to-one relation, correct? Because we have many values of x corresponding to one value of y. Nick? Yeah, correct. Yeah, that's right. So on here now, and what we're essentially going to be able to do is assign a test to an outcome. So the horizontal line test, if it passes the horizontal line test, effectively fails the horizontal line test, i.e. that it's passed through multiple things, and it passes the vertical line test, then it's a many-to-one relation. We'll get into the exact specifics about that. Sorry, I'm probably jumping ahead of myself slightly a little bit there. So that graph is a many-to-one. Oh, should I put that there? Yeah, okay. So that graph's a many-to-one function because many values of x. We've asked about shortening this. We'll see. We'll see what happens. Okay. There's many values of x, yeah, map to one value of y. So there's that mapping thing again. So to formalize that, yeah, it's the horizontal line test, which is what we have there. So the vertical line test. So if there's no vertical line meets the graph more than once, then that's considered passing the vertical line test, and then that would put it into one of two categories. And in fact, it's either one-to-one or many-to-one, and then depending on the horizontal line test would define whether it's which one it is. Anyway, so the horizontal line test, so no horizontal line meets the graph more than once. That's essentially the test. I'll just give you yeah, it's probably going to stay in there. I haven't watched any of these videos back, so I'm not sure what the level of sensitivity is on the audio. Oh no, the quality is fantastic. Yeah, sorry. Yeah, if I bring in the I've got a good condenser mic. That would, as opposed to just regular mic. Thank you. Yes. Yeah, we'll try and keep it funny. Thanks. Just so everyone's aware, Josh clapped for me, because I don't know if it was loud enough for the audio to hear. And now we've made full circle. Yeah, like well, that clap. All right. So vertical line test. Now this is like what they've defined there as these tests is passing, because obviously we can pass or fail the test, and neither one of those is necessarily good or bad. It's just an outcome. Cool. If I look here, let's just try on a quick side note to categorize something, and I have a very simple function here. Let's assume that it's symmetrical about the x-axis. It's not, but yeah, let's call that -5. So I've essentially got y equals x squared minus 5. Let's call it that. What's up? Oh, okay. You sure?
Yeah.
Well, what if someone else didn't get it? Run it through me. Not like a sword, but yeah, go on. Okay.
How many
Yeah.
X's are.
Yeah.
So it's -1.
Yeah.
And then later after that you have to prove that it's a relation of
Okay.
that. And yeah.
Okay, cool.
Yeah.
Good to know. All right. Yep. -5. Sorry. Okay, so on this one here, if I'm wanting to categorize this, I can use two tests. One, if I try and use the vertical line test, what does that tell me? It's passed the vertical line test, so that means that it is, at the very least, passing the vertical line test means that it's either one-to-one or many-to-one, right? It's one of these two things. It's either one-to-one or many-to-one, because if it passes the vertical line test, then it's a function, and all functions must be one of these two things. Okay, so now how do I categorize it and say which one of these is it going to go into? Well, let's do a horizontal line test. So horizontal line test, it has passed through more than once on the horizontal line, meaning that it has failed the horizontal line test. Now, if it passes the horizontal line test, passing the horizontal line test would be either many. Oh, sorry. Oh, yeah, no, I'm right. It's many-to-one, or many-to-many. Okay. Now, it can't be many-to-many because it satisfied the vertical line test. So that immediately rules that out. And I am getting way ahead of ourselves here, so that's okay. Like, oh, we've talked about vertical line.
No, but as in which one?
Right, so these are functions. So this pass. So if that passes this, then it's one of these. But notice there is an intersection. There's an intersection between like these two things because this is not a function. Not function. And this is the horizontal line test. Yeah. Yeah. Okay. Yeah. So many to one just clarifies whether it passes the horizontal line test and maybe it's horizontal and vertical. Now I've gotten confused. Yeah, many horizontal to one vertical. Yeah. Okay, sorry. Yeah.
If it passes many times through the vertical, do you say many to one?
If it passes many times, so if we're so many to many, right? So if we actually had a vertical line and our function was passing through at a vertical thing, then that would have to be one to and it was only going. Okay, if we had a straight vertical line, not a function, but that would be a one to many because I've missed out one of them here. Where's my many? Anyway, sorry. Let's scrap that one for now. But that would technically be a one to many, where it's one value of x corresponding to many values of y. We're not going to deal with yet. No, one value of x here corresponding to many values of y all the way up. Yeah. So no, x always comes first. Horizontal line test, that would be, well, I mean, it's one of two things. The horizontal line test tells us that it's a selection of things. It could be a few things. We have to do both tests to know exactly where it's going to go. Okay.
I think I get it.
Yeah. Well, I mean, I've jumped way ahead of things as well, but effectively, the only way to know like exactly which category it falls into, whether it's one-to-one, many-to-one, one-to-many, or many-to-many, is to do both tests and see what the outcomes are. And we'll do a little table of things that, well, we have a little table of things that's in there. Okay, guys, shh. Hello, Josh, turn around, thank you. Here we go. Continuing on, so we have our vertical line test and our horizontal line test. Nathaniel. And depending on the outcome of both of those tests is what's going to tell us where something falls into. So there'll be a good category. There's like an if-then almost situation that we can draw for this. Anyway, so using the horizontal line test with functions. Well, if we know it's a function already, then it can only be either one-to-one or many-to-one. That's the only two possibilities. So using one of the tests will, one or both, yeah, we'll see. Anyway, so the graphs below are both functions. We have, what kind of graph is this? Well, correct, it is one-to-one. I was asking if it was like an exponential function, but you're right, it is a one-to-one function. So the exponential functions are all one-to-one because they don't cross over anything. They're just nice and friendly and there's nothing wrong there. Passes the vertical line test, passes the horizontal line test. If it passes both of those tests, it's one-to-one. So that's what I'll do. I'll draw up a little table of like pass, fail, and what the outcome is. So if it passes the vertical line test and horizontal line test, we'll almost do that. No. Let's wait till the end. Okay. And then I have this function here, which is a parabola or a quadratic, and that's clearly many-to-one. When I say many, it just means more than one. Because here I have a value of +2 corresponding to a value of y=4, and then over here a value of -2 corresponds to that same y value. So we've got many x values corresponding to one y value. Mason and Zach, question? Huh? Okay. Can you follow along with what we're doing at the moment though? Thanks. Got you three? Shh. Thank you. Thanks, Mason. Okay. So, as they're explaining here, so the first graph y equals 2 to the power of x, that exponential one, passes the horizontal line test, which means that it's symmetric in the following ways. Every number in the domain, which is along here in X corresponds to exactly one number in the range, and every number in the range corresponds to exactly one number in the domain. So you can replace domain with x-axis and range with y-axis. It's going to be the same thing. That's effectively what they're talking about. So the domain being all x values and the range being all y values, positive and negative. So that graph is one-to-one because it passes both of those tests, and the function has a one-to-one correspondence between the domain, all real x values, and the range. Well, technically the range is y greater than 0 because y doesn't go negative, because you can't have a negative y value with 2 to the power of x. So that's that part there. If we read the graph backwards, there's never more than one answer still. So that's kind of what they're implementing there about reading the graph backwards. If you read the graph backwards, then if there's more than one answer, then it's going to be failing the horizontal line test. I think, yes. Okay, so the second graph of y equals x squared fails the horizontal line test because, as I mentioned before, when y equals 4, well, there's two possible x values because the square root of 4 is 2 and negative 2. So it's not symmetric vertically, but it is horizontally, but anyway, that's fine. So every number in the domain corresponds to exactly one number in the range, but not every number in the range corresponds to exactly one number in the domain. And they've said, as they've stated there. So that's a many-to-one. We could know definitively, although they haven't stated it there, we could know definitively that that's many-to-one because, for starters, we know it's a function, so it's either one-to-one or many-to-one. Those are the only two options. If I didn't know that it was a function from the start, then I need to run both tests just to ensure that it is definitely one of those things. Yeah, okay. So as they stated there, so one-to-one and many-to-one, those are the two things for functions. So if it passes the vertical line test, it's a function, and therefore we can apply the horizontal line test. And if it passes the horizontal line test and the vertical line test, then it's one-to-one. If it fails the horizontal line test, if it passes the vertical line test, then it's many-to-one. Question? You're in the book? All right. Why aren't you following along with the notes, mate? Okay, so what page? Oh, no, you're on a different page. 5, no, 3. Which section? We're doing I, aren't we? E, F, G, H, I. Part question 3. Which one? Question 3. Which question are you looking at? 3I, A. The circle with the bit part missing from the top? It's many to many because it fails both tests. No, it's not a solid line. So the fact that the vertical line could pass through only at one point doesn't negate from the fact that it could pass through at more than one point. So it's not about where you apply the test, it's about where can you apply the test. Yeah. Okay. Now these functions that we've got with the graphs up here could also, the relations could also be represented in these, I can't remember what these tables are called, but they're tables. And effectively in here we've got function of x between each of them. So we have an input and an output. So the first one is our exponential. Thank you. First one is our exponential. So our input, if we put an input of -2, then that's 2 to the -2, which is clearly 1 over 2 squared, which is 1 over 4, and hence our outcome of a quarter. Remember, our negative powers result in fractions, like moving the whole thing down. Yep, okay. And so +2 to the power of +2 would just be 2 squared, which is 4, so on and so forth. Every number there has a single correspondence. Everything on the left maps to everything on the right. Oh, actually, sorry. Yes, but not the other way around. So not everything on the right would map to something on the left. For instance, I could have a -2 on the right, and that doesn't map to a number on the left. As we can see here, there's no values for -2. Okay. Similarly, on the right one, we have that, and that's telling us we've got many to one. So there's many x values mapping to one y value for a few of them. Using the horizontal line test with relations that are not functions. So again, now we are effectively told, we're effectively told that these are not functions, therefore they have all failed the vertical line test. So we straight away, we know that they failed the vertical line test. So our only options here are going to be one to many or many to many. These are the only outcomes here. If it's failed the vertical line test, it's not a function, so it has to be one to many, which is saying one value of x corresponds to many values of y, or many to many, one value of x corresponds to many values of y, and many values of y correspond to one value of x. Many. It's many, many. There's multiple ones on both sides. Okay. Yeah. So we can see this function here, which is y squared equals x, as opposed to y equals the square root of x, which is just the top or the bottom. We can see that it's already failed the vertical line test quite clearly, and passes though the horizontal line test. Okay, great. So it's failed the vertical line test, but it's passed the horizontal line test because anywhere along here, it's only passing through it once, which means that it's going to be this thing here. So you can see how we could actually, and I'm not going to do it right now, but we could actually construct a table there about, well, if it passes this, then it's either one of these, and if it passes that, and it'd just be like a four-thing table, I think. Anyway, yeah. Whereas the graph on the right, a circle, clearly fails the vertical line test. Guys, are you talking about your test at the moment? Huh? Okay, let me quiet. Thank you. So fails the vertical line test, but also fails the horizontal line test. Now, if I take a thing out here, it hasn't passed through anything. But again, it's not about if it can pass the test, but rather where it can fail the test. Like if it's possible to fail the test anywhere, then it's failed the test. So this one fails both tests and is thus many to many. I feel like that's sufficiently explaining that. Then they have a lot more words there, which you're welcome to read through. It just goes on about, effectively, if we have an equation there of y squared equals plus x squared equals 25, then there's quite a few possible values that can make that true, and different things there. Okay, so then one to one and many, and one to many and many to many. If it passes the horizontal line test, but it's failed the vertical line test, then it's one to many. And if it fails the horizontal line test and fails the vertical line test, it's many to many. You can see over here it's like it's haywire. It's -4 maps to -3, but also maps to +3, and -3 maps to both -4 and +4 because of the nature of the squaring values. Now, this table is true. The table that we were given in chapter 5 has mistakes in it. So we'll keep that in mind. And I've sent in the corrections through, but they haven't got back to me yet on that one. So I guess I could be wrong. It's possible. It's happened before. But either way, one of their tables is wrong because the tables contradict each other. So anyway, one-to-one, yeah, passes the vertical line test. So it's a function. Many-to-one also passes the vertical line test, so it's a function, but fails the horizontal line test. And so the table that I was thinking of would kind of be the opposite of this, like where you've got pass and fail out on the outside and then things on the inside, but it doesn't matter. Either way, they both work. But yeah, that's probably a good little table to have. That would be helpful to have written down somewhere. Okay. Relations, this is part where you guys are going to want to pay attention again. Relations may involve objects other than numbers. So functions and relations don't have to act on numbers, they can act on anything, and all 4 types of relations defined in this section are common in database logic and in maths. And eventually, like when you start going to group theory, all of this is very important in that. Okay. Here is how it gets applied. Now, I've put the solution there because, frankly, it's just a bit tedious to write it all out. So, but we are still going to read through what the situation is. So the firm has 10,000 employees and a database records the postcodes, which we're calling the Y value, of each person, which is the X value, that has nominated, each person has nominated as their home address. So why is this a function? Well, we've got employees and every employee is an individual Y value. And then every person, not every person, has a nominated, the postcode, the postcodes are the Y value and the persons are the X values. Josh, question? No, that's an extension. Extension.
This one, all the second ones are functions.
We'll have to get to it in a sec. It's possible that if there was no parameter to it, then it's a very easy way to work it out, and they could just be flipped. Remember, but flipping those reciprocals. Are you saying the X's and Y's have been exchanged?
Yeah.
So it's inverses.
Yeah.
Okay. I'll have to have a look. Yeah. This won't take too much. Okay. So explain Y is a function and whether it is one-to-one or many-to-one. So it's a function because every person's nominated home has a postcode. So there's lots of people, but there's a fixed number of postcodes. So it won't pass the horizontal line test because there's fewer than 10,000 postcodes. So we have a number of addresses being mapped to a limited number of postcodes. That's it really. Essentially. So if we think of, like this, we've got postcodes, records the postcode Y value that each person X value has nominated home address. So, and then address. And there's going to be many of these addresses corresponding to a single postcode, given that they'd have to, well, at least more than one. So, hence, many to one. And if it's many to one, it's a function. Part B, what change may there be for a firm of 10 employees? What change may there be? A little subjective, but they've said, well, if there's only 10 employees and they all live in different postcodes, then you could have a one-to-one correspondence because it could be one address per postcode. But yeah, not necessarily. I said watch the video, but I don't think we really need to watch the video for this. This one, a little bit more confusing, but so many people, X values. So we've got people, and the suburb, in the suburb of Blue Hills own a pet. So people, and then it was pet owners, I think it is. Owners, or it's pets, it might be pets up here. Can't remember if it's owners or pets, but we'll see. Yeah, okay. So what's the relation? So it fails the vertical line test because many residents have several pets. So we could have a pet here, here, and here, and just one person having that sort of thing. It's a bit of a weird, it's hard to draw a graph of that, but anyway. It fails the horizontal line test because many pets are owned by everyone in the family, so many. So it fails the vertical line test and the horizontal line test because this person over here could also have the same pets. You've got 3 people in the family, if they all claim that those pets are theirs, anyway, many to many. Councils register each pet with only one owner. What sort of relation is going to happen there? One to many, yeah. Yeah, well, I mean, it's written there, but yes, so essentially one person to many pets. You could have 3 pets and they're all registered to you, so a one to many situation there, and that's it. That's us done. So just briefly going back, the other version of this that I was thinking about was like the opposite there, where if we have pass and fail and pass and fail, and I draw that up like so, oops, not like that, then pass is obviously 1-to-1. And this is vertical line test, yeah, vertical and horizontal. Oh, that's hard to write. Horizontal. Which way does the L go? Wrong way. No, I had it right. Yeah, you're right. Yeah. Oh, look at that. Okay, horizontal. So vertical, horizontal. So if it passes the vertical, so it's failed the vertical line test, but passed the horizontal test, then it is a one-to-many. Obviously, if it fails both tests, it's many-to-many. And if it's passed the vertical line test but failed the horizontal line test, then it is a many-to-one. And we can see this one's are functions, and these are relations. I mean, technically they're all relations, but these ones aren't functions. So I should just say, yeah. Is that okay? Kind of see that? It's just the opposite of that. The insides have been put out and the outsides have been put in. And that's it. We'll leave it there.